Welcome to my session on why observability solutions need agents. I tried to do a James Bond theme in the beginning, but it didn't work out. So if anyone here just came in for the James Bond jokes, I didn't manage to put them in. Sorry. But I hope you have a nice time with me as well. My name is Dominik Süß. I work as a developer experience engineer for Grafana Labs. Now, that's a pretty unusual title. You're used to hearing DevOps engineers or developers or SRE. So what does that mean? In a usual company, this means making sure developers can do their job efficiently, so optimizing CI pipelines, making sure build tools work. But as we are a company providing solutions for developers, that's kind of an interesting perspective to be in. So my job is to optimize what our engineers build for end users. So it's a mix of user experience engineering with a more technical focus. And one of the challenges we often encounter is people not even getting through the first few steps of Grafana Cloud. So my specific focus is Grafana Cloud. Grafana is a visualization software. And for us to visualize data, you need to get data to our software. And many people fail even before their data reaches our software. That's bad. That's something we need to optimize. And one thing that's often a source for confusion is agents or collectors or vector or whatever you want to call it. Those are all things that don't seem obvious if you're not deeply familiar with the subject matter. So I want to demystify them today so everyone leaves this room knowing what a collector is, how you can deploy it, and why you even need it in the first place. So digging into the first concern, what people actually want out of a observability solution is to see their data. They want to see their traces, they want to see their logs, they want to see their traces, already said traces, see their metrics, and have it all in one place. So they don't want to bother themselves with setting up pipelines, making sure the data arrives correctly. But sadly, it's not that simple. So the first approach could be, you have your application, you have your telemetry database. That could be Prometheus, Mimir, Loki, Tempo, Jaeger. They're all different kinds. Doesn't matter for this talk. Just see this as a place where you store your data. The first approach, yeah, we just have our application, send data directly to the database. No big deal, we're done. It works, but it has some problems. So first, the advantage, of course, this is a simple architecture. We have our application, we have our database, nothing in between. It just works. We don't need to annoy site reliability engineers with yet another thing to maintain. We don't have to request more quota in our Kubernetes namespace. We just send the data there. But there are some negative aspects as well, as you might have already guessed. Changes require redeployment. Every time I want to send stuff to a different database, I need to redeploy my application. If I want to add another label onto that, redeploy our application. If I want to censor some information that's maybe included in our log lines by accident, redeploy the application. If my application crashes, can you be sure that your telemetry data or the information about the crash has been sent? I wouldn't be sure about my applications. The data is also hard to enrich. Say, for example, you're running your application in Kubernetes, and you want to know which pod your application was running in. If you're just sending the data straight to the database, you need your application to implement the logic of figuring out where am I running, which region am I running in, which node am I running in, namespace, environment. That all needs to be passed through your application. You have limited buffering. Every single thing you cache in your application is memory that's taken away from your productive use of your application. And you're very locked to the backend. If you're not using an open protocol to ingest the data, and you pull in some proprietary SDK, changing your entire metric strategy or traces strategy will have you go into every single one of your application, ripping out SDKs, reconfiguring stuff. And if you just want to try out a new solution, that's pretty much locked in. There's also limited ways to control costs. If you're sending excessive amounts of logs, excessive traces, you can't really slow this down from the application perspective without knowing what else in your environment is producing these signals. Forgot to click the slide. So there is a different approach. Who here is familiar with Prometheus? Anyone? Yeah, OK. So if you have used Prometheus before, you will know that it pulls the data instead of sending it. This has some advantage. Again, very simple. The database is pulling it directly. But that's only really possible for Prometheus. There is no such way to do this with logs. You can't do it with traces. It offers some enrichment capabilities. Since Prometheus needs to know where to get the information from, it already knows where your service is running. But you can't do much more than that. And obviously, mostly Prometheus supports this. So you won't find any logs database that pulls logs from your application, at least as far as I know. So what if we could combine the advantages and disadvantages and just put something in between? And that something is an agent, and they exist. There are many different flavors. So I just pulled some logos here. We have Grafana Alloy, which is our distribution of the OpenTelemetry collector. We have the OpenTelemetry collector. We have Vector. We have FluentBit. We have the Datadog agent. Those are all different flavors. They basically all do the same thing. Take some data, send it to the backend. And that's where most of the tutorials end. They just tell you, yeah, go ahead, deploy this agent, and everything will work. You don't have any explanation as to why this works, why you need it in the first place. You don't get the advantages. You don't know how to deploy it, because if I'm running in Kubernetes, do I need one agent per application, 2, 3? Is it dependent on the nodes? Do I need multiple per my cluster? Can I scale this somehow? And this is the reason why I decided to hold this talk. But before we go deeper into terminology, we have to get something straight. Who here knows what OpenTelemetry is? I flashed it on screen. OK. Who here knows what OTLP is? OK. Who of those can tell me the difference between OTLP and OpenTelemetry? Yeah, OK. I see one maybe. So OTel is a mess, but in a kind of good way. So OpenTelemetry is a set of standards for telemetry data. Telemetry data in this case means logs, metrics, profiles, traces, all kinds of different signals that your application can send. So OpenTelemetry, a project designing standards around this use case. OTLP is the OpenTelemetry line protocol. That's a specific transport. So that specifies on the network level what order should my bytes be in for the other side to receive it in a standardized way. And then there's also the OpenTelemetry SDK, which is yet another component, which is also OpenTelemetry. And those SDKs are application-specific libraries you can embed in your application so they can produce traces, metrics, logs, profiles in a standard way that's consumable by every other OpenTelemetry-compatible solution. So the reason why I wanted to get into this is because we can mix and match protocols and a whole bunch of other stuff. This is what an agent or collector looks like on the inside. Your data arrives at one end and goes out the other end. The first step is you ingest the data. This can happen through OTLP, which I just mentioned. But if your application is older and doesn't support this standard yet, it also supports various other formats. So you can ingest data in the Prometheus format that many of you already know. You can ingest data using syslog, Graylog, Elasticsearch protocols. You can take all of these protocols and just send them to the same collector. You also have some application-specific extractors in there. So if you're familiar with the concept of exporters, you can connect this agent or collector. I will use these terms interchangeably. You can connect this piece of software to your database and have it run queries against it to get some data out of that. That's pretty useful if you, for example, want to monitor your Linux host. You can run I think it's the Unix exporter. And that's part of the collector. It automatically gets all the interesting information, CPU usage, memory usage, and ingest it so you don't need to run yet another component. The next step in the pipeline is to process that data. We can do a bunch of interesting things with it. One thing is to just relabel it. If you receive some information from your application you just know is wrong, you can relabel it at that point. You can add labels, remove labels. You can generate new data, which is, in my opinion, the best use case. So if you receive a bunch of logs, you can turn those logs into metrics as well. You can also turn traces into logs and kind of mix and match between telemetry signals. You can do sampling. So if you know you're sending a lot of data, you can say only keep 10% of that data and discard the rest of it. And that discarded amount never makes it to your database. You don't have to pay for the usage of that. And you can do rudimentary forms of multi-tenancy. If you have one collector and many different teams sending to it, depending on where the information originates from, the collector can send it to different backends. So your team A can only view their own metrics, team B can only view their metrics, and that's something that's pretty useful, especially in a Kubernetes context. The last step is then to send the data out. Again, OTLP here is probably the most useful option since many backends support this already. But you can also do Prometheus remote write it out to a file, many proprietary exporters as well. So really, it's up for you to choose. And you can see why this might be useful if you have one vendor on one application, a different vendor in a different application, and yet another vendor supplying your database. You can pipe this all through a collector. It will standardize on one specific format and send it out the other way, which allows you to be locked in less, but and be flexible with trying out new solutions. This is what the configuration usually looks like. This is just a random code snippet from the OpenTelemetry collector. You can see the pipelines roughly here. You have your receivers, which are receiving in the OTLP format. We have processors. We're limiting the memory. We're batching the requests, so we reduce network latency. And then we're exporting it on the other side. You can define different pipelines for different telemetry signals, all well and good. And every exporter or collector is configured roughly the same way. You always have these stages that the data flows through. So now we know how we get the data from the collector to the backend, but how do we actually send the data to the collector in the first place? Because that's something we need to take care of it as well. And a comprehensive observability strategy starts at the application. These are the questions I usually have to go over with people. Do I want to push or pull my metrics? Do I want to do delta metrics or cumulative metrics? Do I want to use Prometheus or OTel? Do I want to log my log lines to a file, or do I want to send them across the network? Do I want to log them using JSON or log-FMT? And for traces, it's probably the most controversial point is where you do sampling. You can either, at the start of starting a trace, say, I don't want to receive this trace, don't record it at all, or you, which would be head sampling, or you can do tail sampling. When you have gathered all information about the trace, make a decision if you want to keep it around or if you don't. And the last part is just, do you want to enrich your data on the client or the collector? My personal recommendations would be to pull metrics. I like it more just because it shifts the burden from the application to the collecting side, where the collecting side can decide how often do you want to get these metrics. So if a system is overloaded, you can say, OK, I will slow down collecting metrics for now. Cumulative metrics, I forgot to mention the difference before. Delta metrics are you only submit difference to the last known data point. Cumulative metrics, you get a big sum which is already pre-calculated for you. I like cumulative metrics. They're easier on the receiving end, also easier to implement on the application side. You only have to increment the counter. You don't have to keep track of what was the last information I sent. And in the discussion Prometheus versus OTel, when I made these slides, I was strongly on the side of Prometheus. Now I'm somewhere in the middle. Choose the one which has better support from your application framework. If you have a native Prometheus integration, use that. Don't bother with the OpenTelemetry stuff until you really need it. On the log side, I prefer logging to files. Simple reason, it's more failure resistant. Because in the worst case, if your network goes down, you can still take a look at the logs and see what happens. You can resume from a later point, where with network directly sending them, it's harder to do that. Sending them to a file, by the way, also means printing to standard out. In Kubernetes, standard out, standard error are your best friend. And that's also the reason why I prefer log-FMT, which is a structured log format, which is not as dense as JSON. Because if you're in an incident and you're navigating around in your Kubernetes cluster on the command line, and you run kubectl logs, and you get a bunch of JSON, you don't want to look at that. Don't bother with it. Write log-FMT. It's much easier on the eyes in the moment where it counts. And you can still parse it just the same way. Tail sampling is, one sentence, just a better thing. And collectors have more information about your application, so you want to enrich them there. So now I talked about how we get the data from the application, but still haven't answered the questions, how many should I deploy? Where should I deploy them? Or should I deploy them at all? I think you should always deploy them just for the resilience aspect. And if you deploy them, start simple. Just have your application, send it to one collector, and send it to the storage. When you add another application, try to see if it works, send it to the same collector. If you reach scaling issues, then you should start considering deploying multiple ones, or if you reach security issues or permission issues. But start simple and work from there. You can also, so that's the most simple pattern right there. Application sends to the collector, sends to the backend. In some cases, it can be useful to have one collector per application. That's what we call the sidecar pattern. This is useful if your application exposes sensible metrics and you don't want to have them on the network at all. You can have one collector just for this specific application, get the metrics or logs or traces, redact sensitive information, and send it off. One use case where I had to deploy this pattern was an application that had a very sensitive endpoint where it was exposing the metrics, but it was also exposing admin controls to basically destroy the whole basically tear the whole system down. So we deployed the collector with each instance of the application and locked down that port from the outside. So only the collector sidecar was able to fetch the metrics and then send them off later on. Another useful pattern is deploying them per node. This is especially useful for logs. If you have services running on nodes, they're most likely logging to the system journal or a standardized log location. There it makes sense to just have one collector per node, scraping those logs files, sending them off. You don't need one per application. Logs are pretty easy to handle. And this also scales with your node count. So if you have one per node, if you increase the node count, you can be pretty sure that you will never have an issue of one collector being overloaded because there are too many logs flowing through it. What else? Why is there a difference here? Yeah, collecting logs. As I just mentioned, sidecar pattern, very useful for logs as well. So if you have an application that's writing logs to a random file in a container, you can deploy a sidecar with it that turns it from logging to a file to sending it off directly. Again, Kubernetes context, very useful. Have it as a sidecar deployment, listen to that one file, send it off to a more centralized location. Node pattern, as I just mentioned, deployed on the node, listen to standard error. This is what most Kubernetes logging solutions do. And there is an issue with that. If you're using a cluster that you don't own and don't have cluster admin permissions, it's possible that you're not allowed to deploy a daemon set there. So one situation where this could be the case is a shared OpenShift environment. You want to collect your logs, send them somewhere else, but you can't just deploy a daemon set. What you can then do instead is use the Kubernetes API directly. So you can basically run kubectl logs every minute, get the logs, send them off. That's useful if you have limited access only, but it's very heavy on the Kubernetes API. Now, as I said, start simple, scale out afterwards. If you want to scale, things can be tricky. If you're pushing metrics, that's not an issue. You put a service load balancer in front of it, Kubernetes-style network level load balancer, should work. But it's not really fair. Because if one application starts emitting a bunch of data, a bunch of metrics, logs, traces, it always gets routed to the same collector. Then this collector is overloaded while the other ones are underutilized. Not the best situation. And to go around this, you have a gRPC-aware load balancer. OpenTelemetry line protocol is based on gRPC, so you can route per request. And if one application starts sending out excessive amounts of metrics, it will be evenly distributed across all the downstream collectors. For pull-based metrics, this is a bit more tricky. So if you have 10 applications and you have 3 collectors, then you have 30 data points, since every collector is scraping every single application. And then to solve for that, you need to put another layer in front of that to deduplicate across that. And if you have that at multiple layers, it can get messy real quick. So, what? I expected a different slide here. Never mind. So this is one way to solve for it. There is a Kubernetes-specific way to solve for it, which I'll apparently get back to later. But for logs, this works. Because in logs, you can split up, have one collector only collect logs for a single application and drop everything else. That's the slide I was looking for. In Kubernetes, there's an interesting component called the target allocator, which allows you to define a service monitor, which you might be used from Prometheus. So you define a set of applications you want to listen for metrics. And the target allocator says, this collector, you collect metrics from this pod. This collector collects from another pod. This collector collects from another pod. And that way, you get around the issue of having all the data points twice and needing to deduplicate afterwards. Target allocator, another component to deploy, another component to manage. There is one other way. This is the only slide that's a bit biased. So our flavor of the OpenTelemetry collector, Alloy, has support for clustering built in. So if you deploy a cluster of Alloy instances, they can talk to each other and figure out, we're scraping the same set of applications. You take care of this application. I'll take care of the other application. And we'll divide it out between us. So you don't have to deploy another level of collectors or the target allocator. This also works outside of Kubernetes, of course. So those were a bunch of things you can do. What are the things you should do? If you are just starting out on your observability journey, then you will probably not have any instrumentation set up yet. You will want to start instrumenting early. Start projects with observability in mind. If you don't have that capability, focus on traces first. If I can give you one advice, if you're starting out with observability, start traces for the simple reason, if you have a trace, you can get a metric. If you have a trace, you can get a log. It doesn't work the other way around. If you only have the number of requests, you will never be able to reconstruct the path a user took through your application. If you have a log, you might be able to convert that to a trace, but it's harder. If you just go with traces, you will have all the observability needs covered. You should also keep consistent. So I mentioned before that you can mix and match protocols, go from one format to another format, but those conversions can be messy. Stick to one format you like and continue using it as much as possible. Obviously, there will be cases where it isn't possible. Try to stick to one single protocol. There's also another aspect of the OpenTelemetry project, which is OpenTelemetry semantic conventions. These define how labels, attributes, metrics, services should be named inside of your telemetry pipelines. So they will give you guidance on, if you have a network address, what should you call this attribute? If you have a port, what should you call this attribute? If you have a HTTP method, what should you call this attribute? Take a look at them if you're instrumenting your own applications, because it avoids the issue of having 5 teams call the same thing by a different name. If you have that situation, it's messy to convert between or to jump between one instance and another instance. Just keep to conventions, make it easy on yourself in the future. As you might have seen in the slides before, you can also chain the collectors. So if you're in charge of designing an observability strategy for a large-scale Kubernetes deployment, you might have one collector per namespace, and those are all aggregating to one per cluster, which are all aggregating on one central level. So this allows you to separate the teams, make sure every single team has their own dedicated resource, but still aggregate up top and keep it all in one place. This also allows you to give your team permission to customize their own collector. They might want to use some additional features so they can have it in their own little namespace collector, and your observability or infrastructure team can take care of more big picture concerns like which database do we send this to, without having to go to each team and say, you need to adapt this now. And one last thing, if you know you're going to scale out eventually, maybe separate per telemetry type, have one collector only deal with logs, preferably on the node level, have one only for metrics, and have one only for traces. That allows you to scale independently, because you probably won't have as many metrics as traces. You won't have as many logs as, logs as traces will. You will have many traces. That's what I'm trying to say here. And on the scaling strategies, collect on the node level, connect your logs at the node level, and cluster the metrics, load balance the traces. Now, this was usually where the presentation ended, and I had a last-minute addition, which I then forgot to add a slide for, but I will tell you about it anyways. So if you go back to this place where you have multiple collectors, maybe you have one per team, maybe you have one per region, per namespace, per whatever, and you want to manage them centrally, that can be a pain as well, since you now need to manage configuration files across different teams, across different environments. But there are upcoming changes for that. So there is a protocol out there called opamp, which allows you to centrally manage multiple instances of the collector. which can be useful if you don't want to remote into every single instance, change the configuration file, redeploy, go to the next instance, change the configuration file, redeploy. And it allows you to manage your configurations centrally and apply them to different collector sets. We have this feature available in Grafana already. So if you're using Grafana Alloy, you can now centrally manage all your collector instances and say, I have this configuration snippets, place it on nodes in region A. I have this separate snippet, place it in nodes on region B, without you having to manually go in and change everything. We're looking into adding support for op-amp for the OTA collector as well. Currently, it only works for Alloy, but it's definitely something we're interested in contributing. So yeah, those were my ramblings. If you have any questions, go ahead, ask them now, or meet us at the Grafana booth. We're in the E section behind there. I think I saw many of you there already. Get some stickers, ask more questions about observability, and I hope you got at least something out of this talk. Thank you. Yeah, I hear a question in the back.
Do you have any recommendation for instrumenting Java apps, like Java agent versus dependencies straight on class file?
Yeah, so the question was if we have any recommendation for instrumenting Java apps. In the Java-specific case, I personally tend to use the agent, the Java agent. I think it's the easiest way and the most complete way in the Java ecosystem. If you can't use the agent for some reason, or the next best thing is, of course, instrumenting the application yourself using some dependency injection framework, or I know there are wrappers out there for Spring which automatically inject all trace information in there. I heard good things about Quarkus as well, but I've never tried them, so take that with a grain of salt. But if you can't touch the application and for some reason the agent doesn't work, we have a separate tool called Bela, and it allows you to use eBPF to inject itself into all kinds of processes, not limited to Java, but it supports Java as well. You can deploy that on a cluster level and get traces and metrics for all of your applications in one place. So yeah, take the Java agent. If not, take language-specific SDKs. If not, use eBPF. Any other questions? Yeah? That's a good question. So the question was, how do we handle tail-based sampling if we have multiple levels of collectors? So the straightforward answer is keep the information as long as possible and then do tail sampling at one specific collector. But there is also another approach that we usually take. So what we do is, for most things we care about, we generate metrics from traces. And that allows us to generate the metrics early on. Metrics are way easier to aggregate than traces. So we generate the metrics and sample early on. If you have enough scale, then it doesn't really matter if you do sampling on each collector individually and then keep it all, or if you aggregate it all. So converting to metrics early allows you to keep the information while only sending the required traces on to the next level. And there are also some protocols, I think, which allow you to communicate between collectors, but I haven't looked into them that much. Other questions, concerns? Yeah, if anyone realizes after an hour, oh shit, there was a question I wanted to ask, head over to the Grafana booth. We're happy to help you out. See you around.